Hi everyone, welcome to the 2022 Opportunity X Summer Camp. We're super excited to be hosting these 6 classes where we're going to be walking you through a bunch of different science and engineering experiments. My name is Sabrina, and today I'm going to be leading you through the straw rocket experiment. So I'll also introduce you to some of the other volunteers we have with us at the summer camp. So the other experiment leads are Renee, Stephen, Sophia, Melody, and Brian. And some of our volunteer teachers are Dami, Angelina, Audrey, Tony, Michelle, Tiffany, Caroline, and Maya. All right, so throughout the summer camp, we're going to be having a point system where you're going to have lots of opportunities to earn points. And some of these opportunities include attending class, having your camera on during class, asking questions, and answering quick quizzes correctly throughout each day. And at the end of the camp, we're going to be tallying up the points for each student, and the students with the most points will be receiving gift cards and prizes from us. So make sure to participate as much as you can. All right, so before we get to the actual experiment, there are some basic concepts that we need to know first, such as mass. So mass is the amount of matter in an object, and it is usually measured in kilograms. And everything that you see around us has mass, including yourself, your water bottle, your computer. One thing to note is that mass is not a force. So lots of people get mass and weight confused, and they are very similar, but the difference is that weight is actually a measurement of force and mass is not a force. So you might know that any force is just a push or pull. So for example, if you pull a door to open it, you are exerting a force on that door, or if you are pushing a box, you are exerting a force on that box. And one very special type of force that is all around us is gravity. So gravity is this invisible force that pulls objects together. You might know that the reason why we're able to sit and stay on Earth's surface is because Earth has a very strong gravitational force. The reason why its gravitational force is so large is because the Earth is very massive. So if an object has more mass, it's going to have a larger gravitational force. If the object has less mass, it will have a weaker or smaller gravitational force. Gravity is also the reason why our planets in the solar system are able to stay in orbit. So now we have our first quick quiz. So each of these quiz questions are worth 5 points. And if you think you know the answer, just go ahead and private chat one of the volunteers your answers. So the first question is mass the same thing as weight? And the second question is, do you think the Earth will have a larger or smaller gravitational force than Jupiter? And I'll give you guys a few minutes to answer these questions. All right, so let's go over the answers now. For the first question, the answer is no, because weight is a measurement of force while mass is not, but they are very closely related. And for the second question, Earth will have a much smaller gravitational force because it is less massive than Jupiter. So if you remember, an object with a smaller mass will have a smaller gravitational force. So congrats to all the students who got these questions right. And the next concept we're going to talk about is velocity and acceleration. So velocity is the speed and direction of an object, and speed is just how fast the object is traveling. For example, a car could have a velocity of 25 miles per hour to the left, and 25 miles per hour, that is the speed, and to the left is the direction. So it's really important that when you're talking about velocity, that you make sure you have both components, speed and direction, together. And acceleration is the rate at which an object's velocity is changing. So if you say that an object is speeding up or slowing down, the object is undergoing acceleration. For example, that same car that is traveling 25 miles per hour to the left could be undergoing an acceleration of 2 miles per square hour to the left. And we know that this car is speeding up. We can tell that the car is speeding up because the car is already traveling to the left, and now it's undergoing a positive acceleration because 2 is a positive value and it is staying in the left. So basically it's already traveling to the left and now its speed is increasing as it's going to the left. An object could also have an acceleration that slows it down or changes its direction. So a lot of people tend to forget that changing direction is another form of acceleration. And it is because direction is another component of velocity. So if you have a car that is traveling at constant speed, if it's always at 25 miles per hour no matter what, but it is going in a circle, or if it's making a right turn, even though the speed is constant, since the direction is changing, we still say that object is undergoing acceleration. And now for our second quick quiz. Again, we have two questions here. The first one is, if a car has constant speed but is turning around a corner, is the car accelerating? And the second one, if the car has a velocity of 25 miles per hour to the left, what is an example of an acceleration that would cause it to slow down? So if you know the answers, again, just private chat one of the volunteers. All right, now we're gonna go over the answers. So for the first question, the answer is yes, because the car's direction is changing. So remember that velocity includes speed and direction, and if either of those two things is changing, then the car is undergoing acceleration. So even though the car has constant speed and the speed is not changing, since the direction is, then we say that it does undergo acceleration. And now for the second one. So this one is actually a little bit tricky. So we have a car that is traveling at 25 miles per hour to the left, and we have to come up with an acceleration that causes it to slow down. So we can approach this in two different ways. The first way is we're going to focus on the speed. So we know if an object has a higher speed and then it goes to a lower speed, we can say that the object slowed down. So if an object undergoes a negative acceleration, which in this case would be something like -5 miles per square hour to the left, then it's going to be slowing down since the acceleration is negative. Another way to think about it is if we focus on the direction. So if we have any positive acceleration towards the right, then the car is going to slow down. If you think of it as the car is already traveling towards the left, and now it's kind of going to be pulled towards the right, you can imagine that it's going to be slowing down. So even if it's still traveling in the left direction, it's going to be slowing down. So if you had anything like -5 miles per square hour to the left or +5 miles per square hour to the right, then you are correct. All right, so now we're going to move on to the actual experiment. So first, here are the materials that you're going to need. So you're going to need a piece of paper. It would be great if you have access to a printer, since we're going to be using a template. So if you do have a printer, then go head over to the link tiny.cc/opxrocket and print out that template. If you don't, then what you're going to do is just sketch out the template on a blank piece of paper. So if you don't have a printer, still head over to the same link, tiny.cc/opxrocket, and take a blank piece of paper and use a pencil and just try to sketch out the template as best you can. So there are two parts that you're going to need to sketch out. There's one part that just looks like a long rectangle, and then another one that is the main rocket part. If you are sketching it out, just for reference, the rectangle is about 1 inch or 1.5 inches wide, and it's about 4 or 5 inches long. So it would be great if you have access to a ruler and you can kind of measure it out. It doesn't need to be perfect, but please try to get it as close as possible. So sketch out the rocket and sketch out the rocket body, which is the rectangle. The next materials that you're going to need are a sharpened pencil. So find a wooden pencil that is sharpened. You're going to need a pair of scissors, a little bit of tape, any type of clear tape or masking tape would work, and then a straw. So any plastic or paper straw. And if possible, it would be great if you can find pencils and straws that are kind of the same diameter. All right, so now we have the steps to the experiment. So these are the first 4 steps. The first one is to print out the rocket template if you have access to a printer. If not, sketch it out on a piece of paper. The second step is to cut out the rectangle from the template. So the rectangle is towards the right, and just cut it out along the dotted lines. And for the third step, you're going to grab your pencil and you're going to lay the rectangle down, and you're going to put the pencil on top of it and just wrap the paper rectangle around the pencil. So if you go ahead and look at the third image here, you can see how the pencil is being, or you can see how the paper is being wrapped around the pencil. And try to get it as tight as possible. You're going to have to overlap the paper a few times. And then once it's very tight, use a small piece of tape to secure it. The next step is going to be cutting out the rocket part. So go ahead and cut that out. And now we're going to move on to the next 4 steps. So here the first step is to tape the fins to opposite sides of the pencil tube. So if you take a look at your template, you should see that the rocket fins are, they're actually 2. So make sure that you've cut down the middle. And then you're going to end up with 2 fins and tape them on opposite sides of the pencil. And make sure that you're taping it at the end with like the pointy parts towards the back. So go ahead and look at these photos as reference. And then you're going to take the fins, which are the triangular parts, and fold them so that they stick out at from 90-degree angles with each other. So really you should only be folding 2 fins, 1 from each side. And now you're going to push the paper tube down the pencil until the end aligns with your sharpened pencil tip. And now what you're going to do is you're going to wrap or like squish the paper rectangle down around the pencil tip so that it forms this sharpened cone. And this should be the side of the paper rectangle that is not taped to the fins. And you're going to use a piece of tape to secure the cone so that it stays pointy even when you remove the pencil. And the last step is just to take the pencil out and replace it with a straw, and then go stand in an open area and then blow through the straw, and you should be able to see your rocket fly. Okay, so once you're done putting your rocket together and playing it with it a couple of times, go and blow as hard as you can and figure out how far you're able to launch your rocket and report back. All right, hopefully you guys had lots of fun making your rocket and playing with it. Before we end class, we have a few advanced concepts that we're gonna go through. And these are just some concepts that we can talk about after doing this experiment. Okay, the first one is Newton's third law. So you might know of a guy named Isaac Newton. He lived a long time ago, and he was a scientist and physicist. And he came up with 3 laws of motions that are very important and super relevant in our everyday lives. And his third law says that every action or every force has an equal and opposite reaction. So an example, if you push against a wall, the wall actually pushes back against you with equal magnitude. So let's look at this diagram here. We have a person pushing against the wall. That person pushing against the wall is represented by F1. We see they're pushing towards the right, and based on Newton's third law, we know that there is an equal and opposite force, which is F2, and this is the wall pushing back against the person in the leftwards direction. So we can now take a look at this quick quiz question. Say a book is resting on a table. Due to gravity, there's a force that causes the book to push down on the table, right? Based on Newton's third law, what other forces are at work in this situation? Remember that Newton's third law says that for each force, there's an equal and opposite reaction force. All right, the answer is there's going to be a force in the upwards direction that is the table pushing up against the science book. So we already know that gravity is causing the book to be pushing down against the table. So there's going to be a force that is equal and in the opposite direction. So it's going to be upwards, and it's the table pushing against the science book. Okay, so now we're going to understand how Newton's third law applies to rockets. So to do this, we're going to go through another example where you imagine a swimmer is pushing off the pool wall. So again, we know about Newton's third law. The swimmer is exerting a force on the wall, right? The swimmer uses some of their energy to push against the wall, and the wall is also pushing against the swimmer. And since the wall pushes against the swimmer, that causes the swimmer to move through the water and speed up. However, in space, there's nothing for a rocket to push off of, right? It's just an empty space. There's no wall, there's nothing that the rocket can use. So it has to push off of itself. Okay, so how is it able to push off of itself? Well, all rockets have a component known as exhaust, and the exhaust are the fumes that you usually see coming out of the rocket. So if you look at the photo in the bottom right corner, all of those fumes, that smoke, those are all coming from the exhaust. So the rocket will push the exhaust out. As it goes upwards, it's pushing the exhaust out downwards. And based on Newton's third law, we know that the rocket pushing out the exhaust is going to have its own equal and opposite reaction force, right? This reaction force is the exhaust pushing against the rocket. So the exhaust is going to push upwards against the rocket, and that causes the rocket to shoot upwards and accelerate. All right, so those are all of the things that we learned today. If you have any questions about anything, we covered mass, gravity and forces, velocity and acceleration, and then Newton's third law and some of the basic physics of a rocket. If you have any questions, go ahead and ask them now, and then we can review those slides. But if not, please let us know one thing that you learned or had fun doing today. You can just share this in private chat, but if you're comfortable, we welcome you to put it in public chat or to unmute and let everyone in the class know. All right, thank you guys so much. Tomorrow, we're gonna have another experiment that has been organized by Renee, and it is the density tower. So it's a little bit more of chemistry, and it's gonna be super fun. It's at the same time, and we'll be sending out reminder emails. So we look forward to seeing you there. Bye.